This is the May-June 2022 CXC Mathematics General Proficiency Exam, Paper 2. So on the first page, we have the cover sheet with all the details. That in this exam consists of two sections, 1 and 2. Section 1 has 7 questions. Section 2 has 3 questions. All questions must be answered. And you have to write in the spaces in the booklet, not to write in the margins. All working must be shown clearly, and there's a list of formulae on page 4 of this booklet. If you need to rewrite any answer, there's not enough space to do so on the original page. You must use the extra pages provided at the back of this booklet. So yes, candidate, there are extra pages if you need to rewrite any of your answers. If you use extra pages, you must write the question number clearly. The box provided at the top of the extra pages, where relevant, include the question part beside the answer. All diagrams in this booklet are not drawn to scale unless otherwise stated. So what this means is that don't use your ruler to measure the length of the lines and the angles. Okay, because you're not drawn to scale. But using your mathematical skills, your knowledge of geometry and trigonometry, you can calculate the relevant angles and the length of lines, for example. And here we have the list of formulae. This is a formula page. Volume of a prism, volume of a cylinder, volume of a right triangle. These are the formulae. For instance, the volume of a prism is the area of the cross section. It's a uniform cross section times the perpendicular height or length, as noted by the h. The volume of a cylinder, pi r squared times h. You know, pi r squared is area of a circle, right? And when you multiply that by the length or the distance between both uniform or cross section, you get the volume. So it's the area of that circular part, called a circle, times the distance between both circles of the cylinder, which is the height, that distance between both circles. We call that the height. You know, you can call it the length too if it's lying down. And the volume of a right pyramid. Now the circumference, you know, the distance around a circle, 2 pi r. The arc length can be found using this formula. The angle of the sector over 360 times 2 pi r. So theta is the angle subtended by the arc. We have the area of a circle, area of a sector, area of a trapezium, and so forth. And then you have the roots of quadratic equation. In other words, you're finding the value of x. The value of this x and this x is the same, right? Because it's the same equation. The equation must be set to equal to 0. If it's not equal to 0, you transpose the terms until you get 0 on this side. And then you solve it by plugging in those values. No, we're talking about values, we're talking about the coefficients. That, like for instance, a, the b, and this constant c here. You plug it in this formula, and you use your calculator, and you manipulate until you find what x is. And x usually has 2 values. Sometimes it may have 1. I mean, you get 2 values that are the same, so it's just really 1. Alright, then you have trigonometric ratios, sine, cosine, and tangent. Man, you gotta know, hey, if you have a right angle triangle, hey, the side that's opposite this angle is called the opposite, obviously. The side that is next to it is called the adjacent, because adjacent means next to. We're talking about next to this acute angle called theta. We're talking about opposite, this side opposite this angle called theta. And this side here over here is the hypotenuse. It's the longest side. It's like the highest one in a sense. But yes, the highest number in a right triangle is called the hypotenuse. It faces the right angle. And so you're going to use these trigonometric ratios. You know, and it depends. You're combining sides. So the ratio of any two sides, you know, you use sine, cosine, and tangent. So let's say you want to combine adjacent to hypotenuse. Obviously, you're going to use cosine because cosine deals with the adjacent and the hypotenuse. Let's see, cosine. Length of the adjacent side over length of the hypotenuse. Definitely. All right, so let's move on now to some other things. Yes, the area of a triangle. Hey, who knows? We only taught that area of a triangle is half base times height. But looky here. We have some other formulae, like half the two sides that traps the angle C can be found as half AB sine C. And hey, what about if you have all three sides known and with no angles? Then you can use this formula. It's called Heron's formula, or Heron's formula. So it's basically the square root of the semiperimeter. In other words, this S here that you've seen several times, you can find it by just adding up the three sides of the triangle and divide it by 2. So when you divide something by 2, it's like cutting it in half. So we say the semiperimeter. So the semiperimeter will multiply by the difference between the semiperimeter and the first side times the difference between the semiperimeter and the second side times the difference between the semiperimeter and the third side. Difference, I'm talking about subtraction, the result from subtraction. Then we have sine rule and cosine rule. Man, you gotta learn that. The teacher gotta explain that one to you. Hey, or you can check out YouTube. Now let's look at this. The first question. Now these are computation questions because computation, you're just dealing with addition, subtraction, and division. There's no words telling you something about how this is to be done. You're just looking at this and say, hey, what do I do first? Do I add first, divide first? Yeah. But the rule is, don't go add first. Use BODMAS. You divide before you add. Okay, so you divide and multiply before you add or subtract. Okay, that's the rule. Remember it. Addition and subtraction should always be done last. So these two fractions here, those with denominators of 6 and 9 respectively, divide these two. Then you go ahead and add 7 over 8. Or you can say 7 over 8 plus the result. Man, you can just plug this whole thing in your calculator too. If your calculator can actually hold all of this one time, then you can just plug it in. It only wants 1 mark. So if you can put all this in your calculator one time, just put it in. But I would suggest, if you're going to do it in parts, remember, you must divide first. Alright, calculator can help you because it says here, using a calculator or otherwise. Alright, then we have this one. You're dividing 8 by the cube of 0.4. So you want to make sure you cube 0.4. Get that answer. Then you're going to take 8 and divide by the result. So, hey, the order matters. In your calculator, you enter 8. Divide. And this is my suggestion. Put a bracket after the division symbol. This line means divide by. 8 divided by. Then put a bracket and then put 0.4 and then cube and close bracket. So what you're telling the calculator to do is to divide 8 by the result of the cube of 0.4. Okay, and so you see these all this work 1 mark. So you really don't need to go and say, boy, I got to work this thing out long way. No, just 1 mark. The answer itself is worth 1 mark. So if you can get the answer alone, that's fine. So calculator is the best option in such cases. Now I would say, just look at this one. You got to plug this in your calculator, get an answer, look, you have to correct it to 2 decimal places. I'm saying this probably is worth more than 1 mark. I'll say this is worth 2 marks. But anyways, you're going to say the square root of 26.8. Then you're going to subtract 2.5 to the power of. You see, when they put the power of button in your calculator, here's what I suggest. When you put the power of symbol, put bracket. Then you put 3 divided by 2, close bracket. So what you're doing is you're raising 2.5 to the power of this 3/2 or 3 over 2, which will be in bracket. Alright, and the answer you get probably going to have a long decimal, a long number. What I'm saying is a lot of digits after the point. You want to basically correct this now to 2 decimal places. Decimal places are counted after the point. So that's where now you have to think about how to do that. Calculator won't necessarily do that for you. It can, but you gotta learn that. But anyways, now this requires that you read this question and interpret what it's saying. So here's what I'm gonna say here. I'm not gonna do this one. I'm gonna say to you, pause this video, read it, try to answer it. So we're gonna move on from this. But nevertheless, this is not computation. I mean, it involves computation, but we consider this to be consumer arithmetic, because here you have a case where buying is taking place, right? You're buying. Once you're buying and selling, getting discount, you're on consumer, consumer arithmetic. All right, so we're moving on now. Here we have a ratio. So you want to basically go through this one. Pause the video, go through that one. Now, again, now you're down now to number 2, which deals with algebra. Algebra. So you gotta factorize this. This is what they want you to do. Factorize in quadratic expression. Man, look up some YouTube videos on factorization. You can check out some videos on that and see how to get that done. Now here you have to solve this quadratic, not expression this time, because you have an equal involved. If you look at the previous one, it's the same expression at the beginning here, but it's equal to 0. So what you got to do here? Well, notice that it says expression. Notice that it says equation, but you're both quadratic because of the 2 on the x, right? The power there is 2, so what's 2 is, it's a quadratic. And then solving this, you could either take the answer you got from the top there, as in the pair brackets, equate it to 0, and then you're gonna solve from there. Now you should know how to do that. Check some videos out, or ask a teacher or a friend who knows how to do it. Make V the subject of the formula. You have 2 V's here. How do I make one of them the subject of the formula? Or should I make both? Which one should I make the subject of the formula? Well, guess what? There's a way to do this. You have to figure a way to bring the 2 V's together, as in 2 terms with these 2 V's. And then you're going to factor out the V, and so you're going to put 1 V. And you get rid of the other terms around it. So you're going to basically isolate V. So you're going to get these V's together. On this side, for instance, factor it out because from 2 places. So you have 1 V now. And that V now you're going to basically isolate it. And that's where you have V being the subject of the formula. Alright, so we saw this already. Alright, and now we are talking about direct proportion or direct variation. Man, they're the same thing. So, you read this question, and it's basically equation, right? And then you have given h equal 5.4, p equal 1.44. Determine the value of h when p is equal to 2.89. So, simple stuff. Now look at question 3. Easy as well. This is transformation. So we looked at computation, question 1, and consumer arithmetic. Then question 2, algebra. Now we're looking at transformation. Transformation is geometry, really. Geometry and graphs. But transformation is where we're talking about what? Give me some transformation. You know of reflection, rotation, enlargement, and the one that sounds like transformation, translation, which is it's a shifting, a shifting of that shape, but the orientation remains the same. Yeah. So if you look at these, you're basically not seeing any of these images having the same orientation except for P and S. But P and S have the same orientation, right? But they don't have the same size. They're not congruent. In other words, if you put one over the other, they don't match. One looks like an enlargement of the other. And so we can see that P has enlarged to become S. And it seems like P here rotated to become Q. And it seems like P here reflected in one of these vertical lines to become R. So we're seeing a reflection here from P to R, a rotation from P to Q, an enlargement from P to S. Yeah, but you gotta explain though. You gotta do some explanation, right? When you're describing them, you gotta explain, because with translation, you need a translation vector. With enlargement, you need a center of enlargement. Reflection, you need a mirror line. And a rotation, you need a center of rotation. See? Alright, so you gotta do all of that. And when you're answering these questions, and you're talking about, yes, an image of shape P after translation vector. Yeah, label this image T. So you gotta do that on the sheet on page 10. Alright, so now we come to question 4, which is talking about what? Yeah, our favorite, functions. The functions f and g are defined as follows. F of x, we say f of x. Yeah, I mean, and that's the fancy way of saying, describing this function, which is given by 5x plus 7. In fact, thinking this of an equation is y equal 5x plus 7. And another one, let's say y equals 3x minus 1. But we differentiate them using f of x and g of x, consider them functions. Alright, no. For the functions given above, determine g of 1/3. So basically, you're going to take this 1/3, right? The input here is 1/3. So you input it where you have x, you're going to input it in this function. It's telling you g of 1/3. X here represent all the values, right, in the domain for this function. And then when you put it in, you get out range or codomain. So 1/3 goes into this. 3 times a third is what? If you cut up 3 into 3 parts, 1 out of those 3 parts will be 1, isn't it? So this 1 minus 1 here will give us 0. I'll give you the answer. Oh shoot, no, shouldn't do that. Anyways, so 1/3, 3 times 1/3 minus 1. Yeah? But should we put 1/3 in the f function? No, because this g here suggests we work with this one. This f here suggests we work with this one. Well, not quite. If you look at this f here, you see a little -1 here, which means you want the inverse of this function f. So you got to find the inverse of this. So instead of addition, you use subtraction. And instead of multiplying by 5, you're going to divide everything by 5. So it'd be like x minus 7 divided by 5. That will be the inverse function. And then you're going to drop -3 into that inverse I just described there. So let's move on with our lives. Alright. So let's move on down to. Alright, so we have some coordinate geometry. So we have the equation here, they call it equation. It's equation of a line here. This line they call line L. And we want to write it, give an equation in the form y equal mx plus c. I'm sure you heard of that. Or you might say y equal mx plus b if you're American. Alright, so we want to write the equation of this line in this form. So we're going to say y equals some gradient, because m here just simply stand for a number. The steepness of the line, we call that the gradient. How steep is this line? And we say it's steep by a certain value, a certain fixed value, a constant. And we get that value by basically taking 2 points on this line. And then what we do, look at their coordinates. And we're going to say the difference in the y coordinates divided by the difference in the x coordinates. And that will give us our m, which is known as the gradient. And this c here is the y value of the point where the line intersects the y-axis. So if you notice, this line actually cuts through this y-axis at what? This straight line cuts through the y-axis at what? At 1. And this 1 that it cuts through the y-axis, it means that this point here has 2 coordinates. This point here, that is the intersection of line L and the y-axis. point here has two coordinates. Every point has two coordinates. But in this case, it has coordinates 0, 1, where 0 is the x coordinate and 1 is the y coordinate. So C is the y coordinate of the point of intersection of the line, straight line, and the y-axis. So C here would be what? 1. So when we write the equation, we just simply write in y equal whatever gradient it is, that value, we put back the x. Just as we put back the y, we're going to put back the x, but m and c, we need those numbers, and that's it. Okay? And then here comes a different equation of a line. A different line given by this equation. And what they want to do, they want to find out the coordinates of the point of Q. Right? So where Q crosses the x-axis. So here you have a point Q, right? And Q crosses the x-axis. All right, so let me just read this properly again. The equation of a different line Q. So Q is a line with equation y equals -2x plus 8. Okay, I want to write down the coordinates of the point where Q. Okay, not the point Q, but the point where the line Q. So it should be line Q crosses the x-axis. Okay, so wherever line Q crosses the x-axis, we want to write down its coordinates. Now, every line crosses the x-axis where the x-axis has a y-coordinate of 0. So you put 0 here for the y-coordinate, and then you solve this equation to find what x will be. I mean, that's an easy way to do it because it's only worth 1 mark. Unless you want to plot this on the graph or something. Alright, if you want to find out let's look at this. Write down the coordinates of the point where Q crosses the y-axis. Well, if Q crosses the y-axis, any line that crosses the y-axis, the x-coordinate is 0. In this case, the y-coordinate of the x-axis is 0. The x-coordinate of any line on the y-axis is 0. Hopefully it didn't confuse you there. Again, any line that crosses the x-axis, the point where they cross, the y-coordinate is 0. And in this case, any line that crosses the y-axis, the x-coordinate is 0. Just remember that. So you basically plug that into the equation given for equation Q. Right? So where y is 0, solve for x. Where x is 0, solve for y. And that's it. Simple as that. But you need practice though. You need to get some practice. And somebody to guide you with that, right? Or you can check some videos out on YouTube. Alright, so according to the graph, the solution. So where line Q and line L actually cross each other, you'll have the solution. Another way to do this is just to bring line Q and line Y together and solve simultaneously. If you have two straight lines and you solve them simultaneously, you find x and y. That's where they actually cross. So when you do simultaneous equation, where the two lines cross each other, that's the solution. We have x equal whatever and y equal whatever for simultaneous equation. Yeah, it's the same thing as when you actually plug them up, plug the values, or should I say the coordinates of those lines on a graph, draw the lines, and wherever they cross, the coordinates. That's, yeah, the same thing as solving simultaneously in algebraic form. Okay, so here we have statistics. Alright, so you can pause this video, look through this. I don't think I'm going to spend any time on this, alright? But the point though is here you have some information gathered, and they basically broke this down into the statistical table here. We have the number of students, the midpoint being taken. Basically, look at it, 60 and 80. What's the midpoint? 70. 80 to 100, the midpoint is what? 90. 100 to 120, the midpoint is what? 110. And these are the number of students. They give this information here. To get the F, this is F times X. Remember, F here represents the frequency of the students, or the number of students. But F means frequency, which is also the same thing as saying number of students. And X here represents the midpoint, the value of the midpoint. They just label it X, okay? Since that's the value they're going to use. And then 4 times 7 is 28. So the 4 times 70 is 280. And think about it, is 18. 2 9 is 18. 0 0. Put them at the end here. So it's 1800. So you're basically multiplying this value. So each value from this column will be multiplied by the respective values in these columns. Okay, respective values in of the rows, these columns, to get these here. All right, so that should be easy. All right, so it'd be easy now to you to figure. Okay, so what will go here then? Well, just as how they got these, you get this the same way. It's the mid value. By the way, another way to do this is basically taking 60, for instance, and add it to 8 and divide by 2. So for instance, 100 plus 120, that's 220, and 220 divided by 2 is 110. So you can add 120 to 140 divided by 2 and get this value here. Then you multiply 67 by this value here to get the answer to this one. All right, as simple as that. Okay, and here you have some standard deviation question, some simple stuff. Man, just go to YouTube and look up this whole concept here about standard deviation and the mean height, the mean value. All right, our mean height. And a mean height, just type that's keywords mean height with standard deviation. You're gonna find some videos on that. Look that up and answer that question. Very simple stuff. In fact, if you check it out, just word what? 1 mark. Mighty. Yeah. Okay. So, all right. So we looked at that, and now we have said, now what we're gonna do here is now take these information here, and then you're gonna construct what? Use your cumulative frequency curve. So complete the cumulative frequency table below. You're going to complete this and construct a cumulative frequency curve. All right. On page 19, I think that's already done for you in a sense. They already got some values there. So you're going to basically complete the cumulative frequency curve, in fact. Right? In fact, all right. And then draw the curve. So if you go to page 19, maybe we can do that and see what that looks like here. Okay, look, page 19 here. So you see they actually did some for you. So you're going to start here. You draw your line, straight line to this one, then go up to this one. Remember, you need the next point, right? Based on what you would have gotten from completing the table. And you just link those points up, and you continue and you end it right here. All right. So you'd have complete that cumulative frequency curve. Another name for it is ogive. Some people say ogive. Okay, use your cumulative frequency curve or ogive to find an estimate of the median height of the group of students. So you need to find the middle value and then go across to the cumulative frequency curve, hit it, and then go down. And the value down here will be the median height. Okay, but you can look some videos on that. And here we have now some geometry here, measurements. Surface area. All right. So the diagram below shows a solid made from a semicircle cylindrical base with a rectangular prism above it. All right, so we can see that here, and we have this prism here, rectangular prism above here. All right, and this could have been easily been a cylinder, but it's like it's cut in half. So think about a drum. All right, and then you put it to lie down, and you cut it off as if you're gonna do some barbecue or something, and then you put a fish tank over it. All right, and so this is the shape. So you want to find the total surface area, and you want to find the volume, and basically they give you the formula to find the total surface area. You just plug the values in and get that thing done. All right, so here they want to find the volume of that. So moving on with our lives there. Yeah, so the solid is made up from gold. And 1 cubic centimeter of gold has a mass of 19.3 grams. Cost of 1 gram of gold is 42.62. Find the total cost of, so you're gonna find basically the entire volume there, and then since you know what 1 gram is, then you find the total grams. Then you can actually determine the value there. So some computation there. Consumer arithmetic in that as well, right? Okay, so now we have number sequence patterns to give you two types of arrangement. You have arrangement L, arrangement M, and they built on them. So let's get arrangement L. Here we have the shape here, we have 2 being added, and then we have another one being added. What would the fourth shape look? What would the fourth shape look like? That's what it's asking you. Draw the fourth shape. So draw the diagram of 4 tables using arrangement L. So you have 1 table, 2 tables, 3 tables. Now you want a 4th table by observing the pattern. Notice that these are no longer there when they add the third, huh? When they add the second, I should say. These are no longer there when they add the third, but it's at the end, in other words. But I mean, it depends on how you look at it, right? But you want to be able to do it accurately by looking at patterns. And here, from those patterns, they come up with some information here, right? Like the number of chairs. All right, arrangement L, number of tables. So if we go back to this, what this is telling me is that these are the chairs, and this is 1 table. We have 2 tables now, and this number of chairs. 3 tables and the number of chairs. So you can see that pattern. I imagine you're working somewhere now and you have to think, okay, you need 4 tables. How many chairs would you need? So you have to think about that. And mathematically you can come up with a formula. Alright? And that's, you know, there's a pattern you can see in these things. Right? So that's why this is so cool, you know what I mean? Right? So you have to complete these. Now what these little dots mean here? It means that they would have skipped certain amounts. For instance, 1 table, 2 tables, 3 tables, 4. Don't go to that. 1 table, 2 tables, 3 tables, 4 tables. They skip a certain number of tables. All right, and they go on to another one. So, like for instance, arrangement M. You have 130 chairs. Right. For the same amount of table, for arrangement M, you'll have for arrangement L. But how many chairs would be required for arrangement L under that particular or given information there, which is the number of tables? All right, that would produce 130 chairs for arrangement M. For that same amount of tables, what would be the amount of chairs for arrangement L? So for instance, 2 tables give you 16 chairs for arrangement M, but that same 2 tables give you 14 chairs for arrangement L. All right, but remember, don't go thinking this is 5, so this is 6. No, they actually put 3 dots there indicating that they would have skipped the sequence. So 1, 2, 3, 4. They say, all right, let's skip and go to, like, say 10 or 15 or whatever amount. But you have to know to work backwards, huh? And they skip again, and they go to what? Well, now they're using a formula for it. So basically, from all of this, you can conclude that whatever amount of tables, then it'll be something with n amount of chairs for L, something with n for the amount of chairs for M. Okay, I mean, hey, you can look up some examples of those things. All right, so for question 8, we're looking at this question, linear programming, basically, where you have inequalities and you gotta draw the lines that represents inequalities, and they'll give you scenarios, all right, where you basically have to minimize or maximize costs. So you have a company and you produce a certain amount of cars or minivans, and based on the amount of materials that you have, you only can produce a certain amount of cars, a certain amount of minivans. How can you best utilize these materials to make a profit, or to make the best profit? All right, so you can make a profit, you make a certain amount of minivans, certain amount of cars, and blah blah blah. No, I didn't go into this question, but I'm just utilizing what I'm seeing here in my explanation. So you can read through this question after studying watch some videos on linear programming online, and come back to this and see if you can actually draw this. But for you to do this, you need to know how to draw straight line graphs. Okay, you need to know to draw straight line graphs. So you can look that up as well on YouTube, how to construct straight line graphs. All right, graphs of linear equations, and then you can look up graphs of linear inequalities, shading regions of linear inequalities on a graph, and so forth. All right, and then you can go to now linear programming, where you can applications of linear programming, and then you will see how you can answer questions like these. All right, and look at see here now. So determine the two combinations for the minimum number of cars and minimum go over that again. Determine the two combinations for the minimum number of cars and minivans that can be used to carry exactly 60 people on a tour. Okay, so that's the scenario they gave for this. All right. So the company charges 65 or 75 to rent a car and 90 to rent a minivan. Show that the minimum rental cost for this tour is $990. Again, you want to think through that, right? And here we have one of my favorite topics, circle theorems. Is coming out of geometry. Circle the theorems out of geometry. Once you have angles and using your angle facts to calculate the length of lines or angles, you're talking about geometry there, right? As opposed to measurements, we're looking at volume and so forth, and area and all that. Okay, so we're looking at the circle theorems here. So you need to know certain circle facts or circle theorem facts. All right. Well, once I say circle theorems, these are really theorems. All right, but they're facts nevertheless. If you construct them, you see that they're actually proven. Angle at the center is twice the angle. Well, angle at the center is twice the length of the angle. Measure of the angle, I should say, not length, but angle at the center is twice the measure of the angle at the circumference. Talk about length, you're talking about length of a line. Angle is more of like, they're all measurements nevertheless. All right, so you have many different theorems, like for instance, angles in a semicircle is they are all equal to 90 degrees and so forth. So I'm sure you have learned all of that, right? The sum of angles in a cyclic quadrilateral 360. Well, in all quadrilateral, but opposite angles of a cyclic quadrilateral are supplementary, meaning that they add up to 180. So these are some circle theorem facts. For instance, they ask you this: explain, give a reason why angle HJM. So you're going from point H to point J to point M. The middle point is where the angle, that angle you're looking for. So for instance, we go to from H. Let's try that out. I'm going from H to J, and then we go to M. Where's M? Oh yes, we're gonna go here along this line to get to M here. So again, let's start again. So we start here, H to J to M. So the angle you're looking for is this angle here. You're starting from a point and you go straight. So we don't reach it, we don't have an angle yet. And once we turn on this line, this is the angle that we're looking for. Angle J. But not just any angle J, but angle HJM. This is the angle we're looking for from this. I can think of this angle as part of a triangle here as well too, right? Okay, so you can figure out, okay, how are we gonna come up with what angle this is? So you gotta think through that. Okay, because they actually said this angle here is 38. They actually said that this angle is 38. So you gotta figure out why this angle is 38. All right, so one thing I could think about though is this. If you look at this HJM, this angle here is 38. All right, this actually form a Z. If you notice it, look at this arrow here. Look at this arrow here. And this is this line HJ and this line MK. All right, they're connected by this line MG. So if you look at it, there's a Z here. For these two lines are parallel. Line MK is parallel to HJ. And once you have two lines that are parallel, MK in this case and HJ, and they're cut by a transversal, right? The ulterior angles will be equal. So this angle here will be equal to this one. So a reason you'll put here is that you can say ulterior angles. Well, let me just not say ulterior. Alternate angles. That's the proper term. Alternate angles are equal. So this angle here, angle HJM, is equal to angle. You can actually put that. It's equal to angle HJM is equal to angle. You can say JMK or KMJ. All right. You want to go from one line, from one point to the line, the point that formed where the angle is formed, to another point. So you can say angle HJM is equal to angle JMK or KMJ. Doesn't matter which direction they go for, as long as the M is the center angle. And they're equal because they are alternate angles. That's all you need to put. Full marks. All right. And why is angle MJK 90 degrees? So let's look at MJK. So going from M to J to K. And why is this angle 90 degrees? Well, if you look at it, this angle J, MJK, this angle here, going from M, starting from this point M, going to J, and then to K, this angle here that connects these two lines, the angle here that connects line MJ to JK, this angle here, is actually standing on line MK. And MK is basically a line that passes through the center of the circle. So this line here is a line, what we call it, the diameter. So any angle standing on the line, the center line here of the circle, called the diameter, is actually 90 degrees. In fact, we say angles in a semicircle. So the diameter cuts the circle in two semicircles. And when we say angles in a semicircle, those angles must be standing on the diameter, on both ends of the diameter. So this angle J here, if you notice this leg of this angle J here, this angle J here, this leg here is standing at this end of the diameter at point M. And this is the other end of the diameter, point K. So in other words, line MK is the diameter, right? Oh no, it's the diameter because it passes through the center, 0. And this angle J here has this leg on one end and this leg here on the other end. So it's standing on the diameter. Or we can say the diameter subtends an angle at the circumference called MJK. So either way, angle MJK is, we would say that's angle in a semicircle. Okay, so for this one you can see MJK is equal to 90 degrees, angles in a semicircle. That's the reason. That's it. All right. So, and I'm sure, okay, same thing again. We can look at the others and come up with what those answers are. And here we have bearings. So bearings, basically, you have a movement of from one point to the next. Let's say in navigation, on ships, basically. Usually with ports, you ship up this port and it's traveling on a bearing of a certain angle, and then you gotta figure out, okay, how do I draw this? You have to make sure all these points, wherever you have the items or ships, for instance, you draw your north lines and make sure you use the angles. You use 3 figures, for instance. You don't just say put 65 and the degree symbol. You want to put a 0 in front. It should be a 3-figure bearing. All right, and then for instance like this 148 is 3 figures already, or 3 digits, right? 1, 4, and 8, so that's fine. 65, 2 digits, so you want to put a 0 in front. So let's mention in that 3-figure bearings, we use 3-figure bearings in this kind of questions. And every point again you want to draw a north line. So let's look at this point L here. See this north line here? So I'm gonna make sure you put 1 here as well. I'm gonna make sure you put 1 here as well when you're actually drawing this, right? You have to draw the diagram, and that will help you because you have angle properties when it comes to parallel lines, right? Like alternate angles are equal, cointerior angles, right? Supplementary. You have corresponding angles are equal, and so forth. Vertically opposite angles, adjacent angles on a straight line. Supplementary meaning add up to 180, right? So yeah. So these are some things you want to utilize, and you might find you have to use trigonometry too, like use sine, cosine, and tangent, or even you probably might end up have to use we call it now Pythagoras theorem. Yes, So you want to know your angle facts so you can actually figure out which formula to use. And now you have transformation, right? You have a transformation matrix A with coordinates 0, -1. Should I say elements 0, -1, 1, 0 represents a rotation of 90 degrees anticlockwise about the origin. So it's good to know these. It's really good to know these and how to derive them too, right? And how they affect the rotation or enlargement and so forth of different shapes or images. So you might find different images or shapes undergo certain types of transformation. For instance, this one says write the coordinates of P prime, the image of point P 7, 11 after with coordinates 7 and 11 after it undergoes a rotation by 90 degrees anticlockwise about the origin. Alright, so basically you want to know how to basically deal with those. And here we have a scalar. Here we have 2 by 2 matrix C is defined in terms of a scalar constant K. Alright, determine the value of K given that the matrix C is singular. Well, if a matrix is singular, all it's saying that the determinant of it is actually equal to 0. So it means that you got to know how to work out the determinant. To work out the determinant, you multiply the diagonal entries 3 times 4, and if you put the minus sign and you multiply these diagonal entries 6 times K. And because singular matrix equals 0, you want to put after that equals 0 and then you solve it for K. That's how you basically go you go through that kind of question. And then you have vectors here. All right, so you want to read through this properly and figure out how you're going to do that. Now let's look at this. Let's look at this. If x here is the midpoint, all right, of vector OA, all right, so you see it's saying here that x and y are midpoints of OA, line segment OA. Didn't say as vector, I shouldn't say vector OA, but I'm just saying vector OA because we're going from O to A. That's the direction. I can just say vector OA, right? Or an OB as well too. So y here is the center of O line segment OB. X here is the center. This point X is center of line segment OA. Now, going from O to X is a vector, right? Going from O to X there, that's the direction it's given for that. It wasn't given for the complete thing, but we can figure it out by looking at it that, hey, if O to X, if X is the center of the line segment OA, and OX is represented by the vector U, as we can see here, this view represents vector OX, right? Then going from O to A is going to be what? 2U, because it's going to be U, and this distance here is the same as this distance here. Not only that they're the same distance, but they're going the same direction. So once they're going the same direction and distance, it's the same vector. So this vector OX is the same as a vector XA, because they go in the same direction and they're the same size. So if this is vector U, this is also vector U. So from O to A is vector what? 2U. And from O to B is vector 2V, because O to Y is V, right? So vector OY is equal to V. So O to B is 2V in terms of vector. All right, so that's a concept of this thing. So that's basically, now if you're looking at from B to X, right? Want to go from B to X. Want to go from this point B to this point X. So if you draw a line with a ruler going right across here, you have to travel in terms of the vector that you already know created. So you want to go from B, you can't just go across this line like that because you don't know it in terms of U and V. Because they want BX in terms of U and V. So we have to go with what we already know. So since OB, going from OB is 2V, because we determined that already, right? Because O to Y is V. Therefore, O to B is 2V, because it's twice the amount. Now B to O is the opposite direction, so that's going to be what? 2V. So it's 2V, because we're going the opposite direction to 2V, right? Sorry, I should say negative 2V. Going from B to O is negative 2V, because we're going the opposite direction. So O to B is 2V, therefore B to O is negative 2V. And then we're going to go from O to X now. Remember we're journeying along, we're traveling. Right, we want to go from B to X. So we have to go from B to O, which is negative 2V, plus, and this direction is what? Positive V, U, right? Positive U. We're not going to go from O to A. We're going to just go from O to X, because our endpoint, our final destination is X. So we're going to go from O to X. And that's O to X is represented by vector U. So it's negative 2V plus U. That's the answer for this one. And it's as simple as that, man. Just simple as that, okay? All right. Using a vector method, show the ratio, blah 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 blah. All right, you're gonna have to look that one up. All right. So it is just simple as that. All right. You know, I'm gonna make a video of this thing and to go through them. I'm sure if you look on YouTube, you can find some video of these perhaps already. All right, but I'm gonna make some video of this. If you like my explanation, I mean, it's audio, and most of us are not audio learners. We need to see it being done. I'm just giving you a brief overview, basically. I mean, it's long, yes, because I go through the entire thing and trying to explain how simple this thing is and what type of topics we're talking about. Then, of course, it's gonna be a bit long, and probably, you won't really get it 100%, but you have an idea of what to expect when you learn these topics or what you need to do. All right. So I would say all the best to you, and see you soon in another video. Please, by the way, remember to subscribe so you know when I actually post new videos. That's important. And encourage your classmates, even your parents, to subscribe as well, so they can know when the videos are out, so they can even inform you. All right. But yeah, click on that notification bell too, so you can be notified when you're once you're a subscriber. You want to also hit the notification bell so that you will know or get notification when new videos are out. And take care.